So this will just be from the quiz. Um, so this was the very first question where you had to just read the sign chart. Things I want you to notice at the very top, this value here, not in domain. And because it's not in the domain, we can't ever label that as a max or a min. So I know right away, not in domain, therefore it's not a max or a min. Now, the easiest way to do these problems, I think, are to actually graph the behavior of the curve. Meaning, curve goes up, flattens, curve comes down, curve goes up, flattens, curve goes down. So you can tell that we have a maximum here, and we have a maximum here. We don't have any minimums. Now, if you look at the graph, it does something like this. So what we don't know is which of these would make the absolute. Now, because I gave you the y values for f of x, the absolute max would be the bigger, and that would be this one here. So this is my absolute max because negative 10 is bigger. This is my local max because negative 15 is smaller. So reasoning would be f primed of negative 3 is equal to 0, and f prime changes plus to minus. F of negative 3 is bigger than f of 13. That's why it's the absolute. Now, down here, we get the local. I'm going to give you almost the same reasoning. F primed of 13 is equal to 0, or sorry, equal to undefined. And f prime changes sign from plus to minus. And this is the local because f of 13 is less than f of negative 3. That's what makes that one the local. Number 2, given the sign chart in the table of values. Let's see. Things that you have to notice, there's endpoints here. So this is the endpoint at 2, and this is the endpoint at 12. I can tell by looking at the graph we went up, flattened, down. So this must be a minimum because we went up, we flattened, but then we kept going up. So this is nothing. And then here, we must have a max because after that we came down, and this must be a min because we're not going any lower than that. So we have that at 5, no max or min because no sign change. That's my reason of why there's nothing there. We must have that this here is the absolute max because it's the only max there. How do I know that that's an absolute max? Well, EVT holds for this sign chart. How do I know that? Because I believe I said that f of x was continuous. If I didn't say it, you can tell by looking at the sign chart. It's continuous because there's no cross out, and it's closed because we stopped at 2 and 12. So EVT held. So I have to have absolute. So if this 10 is a max, this has to be the absolute max because it's the only max. F prime of 10 equals 0, and f prime changes plus or minus. F of 2 versus f of 10. 10 is smaller, so this must be my absolute min, whereas this must be my local min. The absolute min versus local, but I still get f prime of 2. Oh, sorry. This is an endpoint. Endpoints are always interesting. This is a left endpoint and f prime positive after. Over here, we would write that this is a right endpoint and f prime negative 4. How do I know that this was the absolute? We would have to say f of 12 is less than f of 2. The smaller makes the absolute min. This one f of 2 is actually bigger than f of 12, which is why it's now the local min. And then I actually added on some problems which I moved, I believe. So I'm actually going to do a sign chart for this problem, which we found the derivative on the quiz, but I didn't make you do a sign chart. And really, that's what I would have made you do. So I'm going to take the function, and I'm going to go through and make a sign chart. So I'm going to start off with my domain, which would be that 16 minus x equals 0, x equals 16. Sign chart would be 16, this would be 0. Put in a number bigger would make it negative, this would make it positive. So I am allowed to take the square root of 0 and positive numbers. All right, so our sign chart's a little odd. We're going to be going less than 16. Endpoint, only right, only right side. Okay, so we get that f times of x is equal to e to the 2x, and I'm actually going to rewrite this here. Set a different color. E to the 2x times 16 minus x to the 1. So, leaving the first, multiply by the derivative of the second. Bring the power down. Leave the inside the same, multiply by the derivative of the inside. Plus, here's the second term, times the derivative of the first term, which is e to the u times du dx. I'm going to clean this up as much as possible. We get a negative e to the 2x, that's this part here, this part here. The 2 is on the bottom, the square root of 16 minus x is in the denominator. The second term looks like everything is in the numerator. Now I'm going to get my common denominator by multiplying by root 2 root 16 minus x. 2 root 16 minus x. So we get the denominator is now 2 root 16 minus x. My first term was negative e to the 2x. And then now the second term, I'm going to do 2 times 2, which is the 4, e to the 2x. And then root of 16 times root of 16 gives us just the 16 minus x. Remember, you're not going to distribute when you multiply if there's nothing added or subtracted. That may sound confusing to some people, but I just want to make sure that you really should be multiplying these two together so that they cancel the root, and then the rest of it is just the 2 times 2 times e to the 2x. Okay. Next part here, let's see what we can do. I think we can factor out an e to the 2x, which gives us negative 1 plus 4 times 16 minus x all over 2 square root of 16 minus x. Let's see. Now I get e to the 2x times, so this becomes 64 minus 4x, and so I end up with positive 63 minus 4x all over 2 root of 16 minus x. So there's the derivative. The next step is to set the derivative equal to 0 or undefined. So we're going to take this to a new page. And I'm going to set my derivative equal to 0, which would be the numerator. And then if I want to set this, the derivative equal to undefined, I would take the denominator and set it equal to 0. So these are two factors. So I would do e to the 2x equals 0, which it can't. And then I would do 63 minus 4x equals 0. X is equal to 63 over 4, which is really close to 64. All right. So let's see. Here, we would get 16 minus x is equal to 0. Square both sides, I get 16 minus x equals 0, so x is equal to 16. And if you remember, we found that at the very beginning also. Now I'm going to go back and check the domain.